Alright, so I wanted to show you real quick a different way you can simplify, where you actually simplify before you do the multiplication or division, or you simplify instead of waiting till the end, you do it before you do the operation. This is also sometimes canceling. I've heard people call it cross-canceling, but this is an example of the type of problem you're talking about, where you do the multiplication, you end up with a really, really big number like this. And I agree, that's kind of a pain in the neck to have to figure out how to simplify whenever you have these really large numbers. Especially with the kids, because they'll start to simplify it and then they maybe fall off and don't get it all the way in simplest forms. So what I've been trying to show them in class is how you can simplify. I'm going to do the same exact problem, but you do it before you even do the multiplication. That way you end up with smaller numbers. So I'm going to do that same problem now. So 12 25ths times 5 36ths. Okay, and before I multiply, I'm actually going to do the same thing I did up here, where I'm looking on the top row, the numerator, and the bottom row, the denominator, for a common factor that both of those numbers could be divided by. But instead of waiting till the end, I'm going to do it with the numbers I have now. Okay, so I'm looking in the top row, so up here, and I'm looking in the bottom row down here. What I'm looking for is if there are any numbers that have a common factor or something that they're both divisible by. I would point out to the kids, what do you see up top and down below on either of these fractions that has the same common factor? And we might notice that 5 and 25 are both divisible by 5. So they would divide by 5. 5 divided by 5 is 1. 25 divided by 5 becomes 5. So we're doing what we did up here, where you're dividing the top and the bottom. We just do it before we do the multiplication. Okay. Another example here is that 12 and 36 are both divisible by 12. So I could do 12 divided by 12, which would give me 1. And then 36 divided by 12 gives me 3. Then I only have to multiply with those already simplified numbers. So 1 times 1 is 1, and 5 times 3 is 15. So you end up getting the same answer you would have up here, but instead of having to deal with all of these large numbers. Okay, I'll do one more example for you, and you can absolutely find videos on this on like YouTube as well. Some of my favorite YouTubers that cover the content we do are, and I'll write them down for you, one called Math Antics, and the other one is called Math with Mr. J. Okay. These are two different YouTubers that cover a lot of the same content we do in class, in short little videos where they'll do examples to help you with the different concepts. Okay, but let me do one more problem real quick. Let's do a division problem. So if I had something like 2 and 11 twelfths divided by 10 20ths. Well, the first thing I need to do is make sure that both of these numbers are fractions. So I'll need to change this mixed number into a fraction. 12 times 2 is 24, plus 11 is 35. And then the denominator stays the same. And when I'm dividing fractions, I told the kids, when you divide, find the second guy or the second fraction, flip and multiply. So you flip this fraction, it will become 20 over 10, and you actually are going to multiply. Okay. Now, instead of multiplying 35 by 20 and 12 times 10 and getting these really huge numbers, this is where I would encourage the kids to look for things that they can cancel. So we're looking on the top row, we're looking on the bottom row. I see the 10 and the 35, and I recognize that both of those could have been divided by 5. You may also have done the 10 and the 20. Both of those would have worked. 10 divided by 5 will end up giving me a 2, and 35 divided by 5 gives me 7. Then I could also simplify the 12 and the 20. Both of those numbers can be divided by 4. 20 divided by 4 gives us 5, and 12 divided by 4 would give us 3. Now that I have these smaller numbers and there's nothing else on the top row and the bottom row that could be simplified anymore, then I would multiply. 7 times 5 is 35, and 3 times 2 is 6. We would turn that back into an improper fraction. You can either do it in your head and think, how many times does 6 go into 35? Well, it goes in 5 whole times, which would be 30, with 5/6 left over. Or if you're not able to do that in your head, I remind the kids that a fraction like this is actually just a division problem. So saying 35 over 6 is the same thing as saying 35 divided by 6. So if you did 35 divided by 6, we know that 6 goes into 35 5 times. 6 times 5 is 30. Subtract, and then we end up with a remainder of 5. But instead of leaving that as a remainder, we can make that into a fraction by making the remainder our numerator and the divisor our denominator. So you end up with the same thing of 5 and 5/6. So I hope this helped. I think that was the issue that you and Peyton were running into, where you have to simplify beforehand so you don't end up with these really large numbers like we did up here. And if you simplify before you actually do the multiplication, it makes it a lot easier. Okay? Thank you so much for helping him with this work, and if you have any more questions, let me know.